Hello everyone, this is Unit 3, Lesson 3 of Polynomial Functions, and specifically today we are going to review or learn about polynomial long division. And before we do polynomial long division, if you haven't already done examples, the warm-ups, then I would go ahead and pause, although I am going to do the last warm-up with you here, the 5,773 divided by 21. But if you want to do the warm-up 1 and 2 before that, you should. Otherwise, you can join me in this warm-up of of just numerical long division. So if you took 5,773 and divided it by 21, and you didn't have a calculator to do that, well, one method you might have learned when you were younger was to put whatever the 5,773, which is your dividend, underneath the bar, and then put the 21, which is your divisor, on the outside. Then you would say to yourself, okay, we're going to take 57 and divide it by 21. The first two digits, 57 divides, or 21 goes into 57. How many times? Hopefully you're saying 2 times. So what do we do? Step number 1, we'll put it up here, or no, we'll put it below. I'm afraid I'm going to run out of room. We divided, right? We divided the 57 divided by 21, and we got 2. And then what's the next step we're going to do? We're going to multiply. So we're going to multiply 2 times 21. That gives us 42. And then what is my step number 3? I'm going to subtract. So I subtract 57 minus 42, and then that leaves me with 15. Right, now what do I do? 21 doesn't divide into 15. So I have to bring down the next digit, which is the 7. So step number 4 is to bring down the next digit. And I go back and I repeat the same process over again. So 21 divides into 157 how many times? Well, I'm thinking 7 in my head because 7 times 21 is 100, or 7 times 20 is 140, and then we add the 7, so it's 147, right? So that's the first thing I did. I divided, then I multiplied 7 times 21, and I get 147. Then I have to subtract, so I'm subtracting, which means I bring down, 157 minus 10, I subtract, 157 minus 147, I get 10. Then I bring down my last digit, which is 3. So I have 103. I repeat the process again. I divide. 21 goes into 103. Well, not 5 times, not quite. So I'm going to say it's 4 times. 4 times 21 is 84. What do? I subtract. 103 minus 84 is 19. So here are some vocabulary words. We have up here, I'll use red. We have, this is called our quotient. This is called our divisor. This is called our dividend. And this is called our remainder. Sorry, that doesn't look pretty. It's remainder. So what do we have? We have 274 with 21 left over. Not with 21 left over, with 19 remainder divided by 21. So that would be 274 and 19 over 21, right? This is your quotient, remainder, divisor, so that's my final answer, if you're going to write it in mixed form. All right, so that was your basic elementary school long division, or maybe middle school, but now we're going to apply this to polynomial long division. So we're going to divide this polynomial 2x squared minus 5x plus x cubed minus 6, and we're going to divide that by x minus 1. So the x minus 1 goes on the outside, and on the inside, underneath this division bar, we need to make sure we have written our polynomial in descending order. So this is not currently in descending order, so we need to take the highest degree term first, which is x to the 3rd power. Then I need to take the second highest degree, which is 2x squared. It's positive, so I put plus 2x squared. My next highest degree, minus 5x, and finally the constant with no number. My x minus 1 is already in descending order, so I'm good to go. Now, we are going to try to follow these 4 steps, but we're going to apply it to the polynomial that we were given. So step number 1, it says to divide. But what do we divide this time? Well, you take the first term divided by the first term. So really, we're just doing a little side note here. X cubed divided by x. What do we get? We get x squared. And I'm going to line the x squared up above the x squared. It's not a big deal, but it does help if you're trying to organize your information. So step number 1, I just divided. Step number 2, I'm going to multiply, right? So I need to do this step next over here. So multiply, that means x squared times x is x cubed. X squared times negative 1 is negative x squared. So I've done step number 2. I've multiplied. Step number 3, I should subtract. So I need to subtract these first 2 terms and subtract x cubed minus x squared from them. When I subtract over here, it was easy with my numerical values that we were just subtracting a number. Here, I'm subtracting the entire quantity of x cubed minus x squared. So for me, I like to subtract by changing the signs. So x cubed becomes minus, and then x squared becomes plus, because I distributed the negative through there. And to be honest, when you do this subtraction, your first 2 terms, whatever you have here, should always cancel. If they didn't, you made a mistake. So we add straight down, or basically we subtract. X cubed minus x cubed is 0, and then 2x squared plus x squared is now 3x squared. Then what do I do last? I bring down. So I bring down my next term. Instead of it being a digit, it's the next term. So I bring down my minus 5x, and I go back to the beginning and repeat the process. So I have my first term, 3x squared, that I need to divide by x. So this is the second time I'm doing it, right? So 3x squared divided by x is going to give me 3x. They're both positive terms, so when I divide 3x squared by x, I'm just get positive 3x. Then I have to multiply. So I multiply 3x times x is 3x squared, multiply 3x times negative 1 is negative 3x. So that was my second step. My third step is to subtract. When I subtract, I change the signs. So the first terms should always cancel. If they don't, you made a mistake. They cancel, so I'm good. Then I have a minus 5x, a negative 5x plus 3x. That is negative 2x, so I get negative 2x. And my last step is I bring down the next term, and my next term is negative 6. I repeat this process one more time. I take my first term, which is negative 2x, and I divide it by this first term up here, which is x. And I would get negative 2 as a result, so that's why I have a minus 2 up here. I multiply through. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. I subtract by changing the signs, right? When you subtract, you distribute a negative, so it changes the signs. First 2 cancel. I end up with a negative 8. Now, if I'm going to rewrite this, I would say that this would be, as a result, it would be x squared plus 3x minus 2. This is my quotient, right? That would be the same as 274. And then wouldn't that be the same if I added plus 19 over 21? Yeah, it'd be the same. So I'm going to add the remainder, which is negative 8 divided by, and then I divide by my divisor, which is x minus 1. Or you can just say this is the quotient, this is the divisor, what we're dividing by, and this is my remainder. Those are the big 3 main vocabulary words you need to know. But there we have it, quotient with our remainder. So this polynomial would equal that if we did that long division. All right. So it says divide 2x cubed minus 9x squared plus 5x by 2x minus 5. So this is already in descending order. We're going to take that, I'm going to put it underneath. This is my dividend. Now, one of the things that I highly recommend you do, you don't have to, is to put a placeholder here. The 0x, notice there is no x. Well, if you put the placeholder, it's just going to help you organize your final answer. So we have an x cubed and x squared. We don't have an x, therefore I'm going to put a placeholder there, a 0x, and then you have your constant of 15. We are dividing this by 2x minus 5, and then I'm going to follow the process that I did before. Step number 1, take the first term and divide it by the first term. So 2x cubed divided by 2x is x squared. Then I multiply through, so 2x times x squared is 2x cubed. Negative 5 times x squared is negative 5x squared. Then I subtract. So in my mind, I'm just going to change the signs. That's what subtraction is. And my first terms should cancel. Now I bring down negative 9x squared plus 5x squared is negative 4x squared. And then I bring down my 0x. Okay, we go back to division. 2x goes into negative 4x squared how many times? So negative 4x squared divided by 2x is negative 2x. I multiply through. I change the signs. And I bring down my negative 10x because I added, and then I get my plus 15. So again, you should be trying to do this on your own. You could pause and try to finish it, right? So try to do this math on your own so you're exercising your brain. Don't just rely on me to do the math for you. Once you get the hang of it, just pause and try it on your own, and then look at my process here. Okay, next, we're doing the same thing. Negative 10x divided by 2x is negative 5. I multiply through. Negative 5 times 2x is negative 10x. Negative 5 times negative 5 is positive 25. I subtract, which means I change the signs, and I get a remainder of negative 10. So when I do my long division, what would I get? So 2x cubed minus 9x squared plus 15 divided by 2x minus 5 is equal to x squared minus 2x minus 5 minus 10 over the dividend. All right, I would try example 3 on your own. So your numerator is what goes underneath the division bar, right? That's your divisor. The denominator is your dividend. Make sure they're in descending order, right? So I'll help you get that set up. So I'm going to put this in descending order, 4x to the 4th plus 3x cubed. Oops, I don't have an x squared, so I'm going to put a placeholder there. So I had to do it in descending order, and I had to put a placeholder. Then I'm going to make sure what I'm dividing by, or my divisor, is also in descending order. So go ahead and pause and try this one on your own. Okay, so did you get a quotient of 4x squared minus x minus 7 and a remainder of 11x plus 15? Hopefully you did. If you didn't, then you made a mistake and need to go back and check. So just to review our vocabulary, right, the numerator, what we are doing, what is getting divided is called our dividend. What we are dividing by is called our divisor. What we get as a result up here is our quotient, and then sometimes we have a remainder left over, or sometimes our remainder is 0. If it's a remainder of 0, that means it divided evenly into that. If it's not a remainder of 0, that means obviously it didn't divide evenly. So let's continue. I would say pause again and try example 4 on your own. Do part A only, and then we'll talk about part B. So part A, we're going to take I'll help you get started again. We're going to take our polynomial, our dividend, x cubed plus 6x squared plus 13x plus 12. Remember, it always has to be in descending order. And we are going to divide that by x plus 3. So pause, do this on your own, and then compare it with my answer. All right, so this time when you did your long division, you should have gotten a remainder of 0. So x cubed plus 6x squared plus 13x plus 12 divided by x plus 3 resulted in just x squared plus 3x plus 4. So it divided, x plus 3 divided into that evenly, and it had a remainder of 0. So what happens with part B if we evaluate f of negative 3? So that means we're putting negative 3 into x, right? So that's a negative 3 cubed plus 13 times negative 3 plus 6 times negative 3 squared plus 12. So I'm going to get negative 27 minus 39 plus 54 plus 12, right? If you can't do the math that quickly in your head, well, just look at it now or pause and try this on your own. So here, my negative numbers, I have negative 66. My positive numbers, look at that, I have positive 66, so that is 0. So when I plug in negative 3 for x, I got 0 as a result, right? So when x is negative 3, y was 0. Okay, well look at this. If we divide by x plus 3, that would be a root of negative 3. If it divides into it evenly, that means graphically there is a root at negative 3. So how do these two things connect? Well, let's talk about it in the next slide. Okay, well, it leads us to the remainder theorem. The remainder theorem says that when a polynomial p of x is divided by x minus a, the remainder can be found by calculating p of a. So if we just plug in this number into our function, then we're going to find out what the remainder is. If p of a equals 0 when we plug that number in, then it means it's a factor of the polynomial, or it's a root of the graph, right? But if we get a numerical value, we have just found a point that is on that graph. So let's talk about that in example 5. It says find the remainder when f of x equals 2x cubed minus 3x squared minus 11x plus 6 is divided by x plus 2. So we have two options now. We can do long division if we want to find the remainder, which is going to be time consuming as you saw from our previous examples, or we can use the remainder theorem. The remainder theorem says just take p of a. Oops, sorry, that shouldn't be a plus sign there. A is equal to what? Well, a is equal to negative 2. So if I take f of negative 2, right, so 2 times negative 2 cubed minus 3 times negative 2 squared minus 11 times negative 2 plus 6, and I need to calculate this. So you guys can pause and go ahead and calculate on your own, or you can follow me. So I get a remainder of 0, right? So negative 16 minus 12 is negative 28. 22 plus 6 is 28, so negative 28 plus 28 is 0. So that means x plus 2 is a factor of f of x. So if I were to divide f of x by x plus 2, I would get 0. So in other words, the point negative 2, 0 is on the graph, and that negative 2 happens to be a root. That's where it crosses the x-axis. Now let's look at the second example. So if I'm dividing this by x minus 1, then a is equal to 1. So I'm going to find f of 1. So it's 2 times 1 cubed minus 3 times 1 squared minus 11 times 1 plus 6. Well, that's 2 minus 3 minus 11 plus 6. So what do I have this time? It looks like I have negative 6, right? 2 minus 3 is negative 1, minus 11 is negative 12, plus 6 is negative 6. So this time we're saying when you plug in 1, you get a remainder of negative 6. It is not a factor. So x minus 1 is not a factor, but the remainder does allow us to see what point would be on this graph if we were to graph it. So when I plug in a 1, I get a remainder of negative 6. Well, that's just my x and y coordinates. So that means point 1, negative 6 is on this function. But when you're doing long division, if you get a remainder, that means it's not a factor. This was a factor. x plus 2 was a factor of the function, x minus 1 is not a factor. All right, try this last one on your own, and then you can unpause and listen to me explain it. Okay, hopefully seeing what I just did above with this problem right here, you can figure out what this question is asking you, example number 6, what it's asking you. So it says when a polynomial f of x is divided by x plus 5, the remainder is negative 2. The remainder is negative 2. So your remainder is negative 2. So circle the statement below that best describes the situation. Well, if I'm dividing by x plus 5, that means I would be using the remainder theorem. It would be f of negative 5. And if I plug in negative 5 into the function, I would get negative 2 as a result. So that means the point negative 5, negative 2 would be on this graph. And what represents that, oops, sorry, that's not a negative number, would be letter D. When I plug in negative 5 for x, I get negative 2 as a result. So the remainder is the y coordinate on the graph. And if it is a factor, that y coordinate will be 0, and it will go through the x-axis at that point. If you get a numerical value, well, you just have a specific point on that graph. Okay, hope it helps. Good luck with homework. I'll see you or hear you or listen. You'll listen to me in the next lesson if you need it. Ask your teacher if you have questions. Bye.